difficulty there, I apologize. Good afternoon, I'm Don Elliman. I am the Chancellor of the University of Colorado Anschutz Medical Campus, and we're a sponsor here. We're thrilled to be a part of this program. You're here today to hear a session on innovations in health and the new dawn of disruptive technologies, which is a subject that on our campus we find ourselves dealing with I think in a very positive way every day. And it's one of the most exciting subjects that we are dealing with, whether it be in bioengineering, as Robin will talk about later, or in personalized medicine that we talked about at lunch today. So we're thrilled to be a part of this. The moderator today is Cary. John is a writer, speaker, curator, focused on social change with an emphasis on design for the public good. He's a founding curator of the Autodesk Foundation, a philanthropic venture of Autodesk, and the first of its kind foundation focused on design for impact. He's a strategic advisor to the TED Prize and co-host of TED City 2.0 conference. He's the author of Power Pro Bono and the founding editor of publicinterestdesign.org. His writing has appeared in the New York Times, CNN.com, the Christian Science Monitor, and Fast Company. So without further ado, Cary.
Thanks. Thank you. The first disruptive technology we're going to talk about are cell phones. So I'd like to ask everyone to silence theirs, please. Don gave a great example of a really positive trend in disruptive technologies that's sweeping campuses across this country and companies around the world. I thought I would provide one example coming from the perspective of a funder. I receive, especially working for a tech company, Autodesk, receive a lot of proposals now that our foundation has been launched for disruptive technologies to bring enormous changes, according to proposals, to the social sector. Most recently, the one that sticks in my mind was a proposal to drop 12 MakerBot 3D printers into a Syrian refugee camp. And of course it was intriguing, and you can imagine the possibilities, and the narrative was actually quite strong. But in that case, there were a lot of issues that I think we were able to quickly point out needed to be addressed, ranging from hardware beyond the 3D printers to software and other challenges, and so we kind of sent that one back. But meanwhile, we've seen some really encouraging examples of disruptive technologies, and we've got an all-star panel up here on stage for you all today to talk through some of those enormous changes that we're seeing. And so I'm going to briefly introduce our wonderful panelists. I'm going to drive much of this conversation for about the first half, and won't require every panelist to respond to every answer. Certainly when they want to, they'll make that known to me. And then we'll, of course, reserve a solid amount of time for audience Q&A. So without further ado, I guess I'll start by introducing Catherine Mohr. So Catherine is, well, she's many things, as many people are on the stage, but she has many incredible titles. She is leading Senior Director for Research and Innovation with Intuitive Surgical. She works at the Stanford Medical School. She's given 2 wide-ranging TED Talks. And frankly, one of the things that interested me most about her was her volunteer or pro bono work for the Second Harvest Food Bank, which we talked about last night, that has little or nothing to do with her technical training in health, but everything to do with the kind of way that she sees the world. And so we're really, really delighted to have Catherine Mohr here. Our second panelist to Catherine's left and to your right is Michael Mussallem, and he is the chairman and CEO of Edwards Life Sciences. It spun off of Baxter International, another major corporation, several years ago now, and Michael was previously with Baxter. And he, in our little email exchange in advance of this panel, talked about several of the innovations that Edwards has brought to market. And one of them requires me to read it because it's a little bit beyond me, but it's a transcatheter heart valve, and I think he'll tell us a bit about what that is. To Michael's left and to your right is Amanda Boxtel, and she's the executive director of the Bridging Bionics Foundation. She's got an amazing story that if you've seen her talks, again, through TED and other venues, she has this amazing life story that she's going to share with us as well. And she brings the absolutely critical and remarkably unique perspective of an end user to a really important conversation on disruptive technologies. And so we're very delighted to have Amanda with us. To her left and to your right is Krista Donaldson. She is the CEO of DREV, Design Revolution, which introduces products that serve people living on less than $4 a day. And so at the heart of Krista's work and the work of DREV is a belief that everyone deserves good design. And when we talk about disruptive technologies, how can we ensure that these technologies reach people at the proverbial bottom of the pyramid or in settings that we know don't normally have access to the kind of resources that may be needed in those contexts. So very delighted to have Krista here. And then finally, we have Robin Shandas with us. He is associated with the University of Colorado at Denver. He has multiple titles, but he works within the Department of Bioengineering, and he's also the chair of that department. And so just an amazing group of people. Thank you all for being with us. They also know that beyond just hearing us talk, you all like to see things. We all, as human beings, like to see things. And so we have a little bit of show and tell. Some of them are so small and fragile that we won't be passing them around, but other items we will be passing around, and I'll just ask that anything that makes its way out in the audience find its way back on stage.
Please.
Please. Prosthetic knees are in high demand, as Krista's going to talk about in just a second here. So I want to first pitch it right back over to Catherine. Catherine, in our email exchange, you said something that was really music to my ears, that it's only disruptive when, and I'd love to have you finish that.
Yes. Making surgical robots, it often gets referred to as a disruptive technology. And I actually tend to push back against that label a little bit and say it's not really disruptive yet. And it hasn't really disrupted until it's fundamentally changed the way that we do surgery or changed the outcomes. And what we're doing with the Da Vinci robot is it allows open surgery to be done minimally invasively. But fundamentally, we're still doing the same surgery inside the body. We're changing the method of access. And so robotics gives us a platform onto which we can bring many different kinds of disruptive technologies. But we haven't really disrupted yet. It's a platform for disruption, but not a disruptive technology in itself.
Great, great. And Michael, why don't you piggyback on that a little bit? You talked about keeping the patient at the center of every innovation, but also aligning the various interests of the many stakeholders, ranging from regulators to partners, vendors, and others, and would love to have you piggyback on that a little bit.
Well, pretty loud, sorry about that. You know, these technologies that really change the way that medicine's practiced, medicine doesn't like to change that fast. It takes a lot of evidence, a lot of care to really convince the world to change the way they practice medicine. And so the influence of many regulators from around the world, the influence of physicians through their societies, principally. The engagement of patient groups is wonderful, although their voice is often not organized and not heard as clearly. But it takes this broad community, and certainly those in government as well, and those that have a stake in paying for these ultimate disruptive technologies. And so bringing that group along with the idea that here's a different way and it's a better way, and here's the evidence that backs it up, is not a small task. It's actually one of the impediments to disruptive innovations is that it takes a lot of inertia to sort of bust through some of that.
Great. And Amanda, several years ago, you had an accident that left you paralyzed below the waist. And so you know well and good that it takes a certain amount of time to realize certain innovations. You've probably seen several innovations come and go. And I know that most recently you've been partnering with a really incredible company that focuses on 3D printing. Can you tell us a little bit about that?
Well, actually, I've been partnering, or the lucky girl that gets to walk in a robot. I'm the end user, and now what I've seen in my lifetime, I've been paralyzed for 22 years. And I never believed in my lifetime that I would get up and walk again. And while I'm not walking on my own 2 legs and feet yet, I am with the assistance of technology. And I see that it's going to be a few technologies that come into play here that will disrupt the healthcare industry and where we're going. And I see that being robotics, the convergence of 3D printing, smart materials, and also then nanotechnology. I had the opportunity to walk in a bionic exoskeleton suit on July 25th, 2010. I remember that day clearly, vividly, because it was powerful. All of my dreams were burgeoning to life in one precious moment. I got up and I can remember after taking those first steps, with that heel strike and a very natural gait, I went home to my hotel room afterwards and cried hard, because that's what I had imagined. Everything came together in that moment. And so the wheelchair's been around for 1,500 years. So now we have the bionic exoskeleton suit that started with the military, with the Hulk. One of the manufacturers started that way, and that stands for Human Universal Load Carrier, built and designed to carry over 200 pounds and to help soldiers endure throughout the day. And then it wasn't until 2004 that that technology then morphed into a medical application. And we're going to see that the military application will then go into an industrial application to help construction workers, emergency first responders. And then the medical application will just continue to get better and better, slimmer, sleeker, sensual, sexy. It'll help the elderly as well as children to get up and walk. But now what we're doing is we're looking at a vision. How do we take what is currently utilitarian and mechanical and turn that into something that is a kinematic art form of design and beauty, where we can weave in an individual's personality and exactly who they are, almost as if their own DNA is being imprinted into the design itself. And so I can talk about that, but that's where I see it going, and we're actually playing and experimenting. We call it an exploration, so that now my role as a consumer, as an end user, goes from a passive consumer that can just choose any manufactured product to becoming one of an active co-creator. And don't we all want to be a co-creator in our own healing, in our own health, whether that's mindfulness, meditation, or working with amazing technologies?
Beautiful. I love the co-creation concept and practice, of course. One of the things that struck me was that when you're talking about that gait and that first touch when you were walking with the exoskeleton, that's something that I very much liken to the work that Krista Donaldson's organization, has done. They have a low-cost prosthetic knee that Krista will tell us a little bit about. And one of the things that, unfortunately, we won't be able to see here today is the comparison between a single hinge joint and the kind of more advanced prosthetic that Krista's team has developed. And it reduces, as she can probably tell us in more eloquent terms, everything from the clicking sound often associated with some of these devices to the way that one's leg actually looks and feels for the person wearing the prosthetic. And so with that, Krista, we'd love to have you tell us a little bit more about your incredible work.
Thanks. And I actually want to preface and say that I'm of two minds about disruption. And one is that you have these giant leaps. And so much of that to me is based in what Amanda very eloquently said, is understanding the users and their hopes and their dreams and what they want. And I think, you know, Amanda wants to walk again, and you want to have a heel strike that is natural, if I can be so bold to say what you want. That's not a better wheelchair. That's dreaming big, and that's thinking, but it's starting with the user and what the user wants. And then the second way I think about disruption, though, is there's a lot of little disruptions to me that add up to a big disruption. And often these little disruptions, which I think is where DREV's value is, can add up. But they're often the little unsexy ones. And the things we focus on, and John's talked a little bit about the mechanism. So this is a single axis. This is a Red Cross knee, about $150. We can pass it around. These are very sturdy. Please don't throw them around, but they're pretty sturdy. This is the first version of the Jaipur knee. This one's a little bit stiff, but this uses a different mechanism that mimics your natural gait. This one is, because it's stiff, it clicks. But this one has been worn now for several years, now 6,000 amputees. But one of the things we heard time and time again is no one wants to click. So you'll see a noise dampener in here. You'll see that this is much smoother design, whereas this guy, you know, if you're wearing it under skirt or pants, it's very clear you're wearing a prosthetic. And that was something that our customers did not want to have. So that's why you have the smoother one. But the real innovation here, and what I would say is the disruption, are these unsexy things. It's a high quality product at low cost. It's affordable. But also it's the delivery model. How do you get these technologies, these disruptive technologies, to people? And that's what's actually causing the disruption. So it's these little additions to me that I think has allowed us to enter and kind of, you know, move around the medical device space in our area, saying, yes, you can develop these very high quality, affordable costs for, quote, the bottom of the pyramid population.
Great. Thank you, Krista. And Robin, I mean, your research and practice is fascinating because you're applying many of these technologies and seeing real developments. Would love to hear more about what those are.
Sure. But let me preface by talking about disruption. I mean, I think about disruption in two ways. It's basically, I think about it as changing the world. And that seems kind of a cliche. You have to change the world. But I look at changing the world in two ways. One is, if I were to create a technology, so, I invented a new kind of polymer called a shape memory polymer that blurs the line between a material and a device. So we developed a new kind of cardiovascular embolization coil. It's a little device that goes in in a kind of solid strand, and then it sprouts all these kind of hairs, literally, and closes down an aneurysm. We call it the medusa. And that technology was set up to address a certain patient population. It was really to change the larger world. So I started up a company. I went and got financing for the company, and we got FDA approval late last year, and it's now being marketed. That's the larger world. But the other part of what I do is the world that's individual to each person. So I have an example here. Unfortunately, I can't pass it around because it's a little fragile. But this is a three-dimensional model of a child with a condition known as cardiac heterotaxy. And so cardiac heterotaxy is a very, very complex congenital cardiac and other organ lesion. Heterotaxy literally means coming from different origins. So typically, the way the heart develops, it starts out in a long tube, and the tube bends. And for these particular patients, that bending doesn't happen correctly. And so the chambers of the heart, every part, the organs, the blood vessels, they all become completely messed up, essentially, anatomically. So the surgeon has to go in there and fix this child's heart. And typically, that surgeon relies on two-dimensional images, right? Plain film, fluoro, MRI, to get a sense of the three-dimensional anatomy. But, so we imaged this child using MRI, and we came up with a three-dimensional structure of this child's heart, and we were able to provide the surgeon with the exact view that he or she would have as they go in, and so they can plan this surgical approach in a very precise way, which, what does it do? It increases clinical outcomes. It makes patient outcomes better for that particular patient. So I cannot go to an investor and say, will you fund a company to do this? Because this only happens in 4 out of 1 million children, right? I can't do it. But when I talk about the world, that family's world is all about this. And that's what we want to disrupt. That's what we want to make better. And so it's this combination of both things. Can I make technology that will address a large group of people? And as an entrepreneur, I have a selfish motive to that. I want to make money as well. Right? And so there's one aspect to that. But there's the other aspect, which is this aspect, which requires, I cannot go to an investor, it requires philanthropic and government support to do this kind of stuff. So this is how I see the disruption. It is changing the world, but the world is defined in different ways.
Great. And just so we understand, I understand at least, what would have happened before you had that technology? What would it have looked like, that process?
Well, the process, so, if I were to be blunt, you hope you have a good surgeon. Still it relies very heavily on the surgeon, but this removes a certain time element, right? So now the surgeon, and this is a team effort, so what the surgeons have done is they've passed this around to their colleagues, They've sent this model to other people, colleagues in Michigan, in France, and received input from them as well about how to plan the surgery. And then based on that input, they're able to kind of be very, very efficient at going in and correcting the defect. So without this, it would have taken longer, which then in the OR setting, that automatically translates to increased morbidity, potential mortality. So those are the kinds of areas that we want to go on.
Great, thank you, super helpful.
But
So
actually,
back to
I was gonna-
Catherine. Yeah.
Before you ask a question, I was going to leap in on that one, just because one of the things that I think is really exciting about this is that you're saying you've got 4 in a million, but the tools that were there, the 3D printing, the scanning, all of these things were designed for much higher volume applications. And the technologies that went into the robotics that are our surgical robot and into the exoskeleton were all developed elsewhere. They were not primarily developed by us as medical device manufacturers, but we were able to go out and appropriate a lot of these technologies that were out there and be able to combine them in new ways that allow us to serve these smaller populations. And this is one of the things that you can create revolutions by going and playing with other people's toys and putting them together in a new way that's very synergistic.
Great point, great point. I'd like to talk about the process of bringing one of these disruptive technologies to market. And I think we've got at least a couple of people, several people on the stage, but I'd like to focus in on Michael and on Krista, and starting with Michael. Walk us through the valve that you developed, and talk about, in your email, you talked about the decades-long kind of gap in innovation. I'm paraphrasing, but we'd love to hear more about that process.
Yeah, well, just to go back, remember you have 4 valves in your heart, and the valve that tends to fail most often is your aortic valve, when it sits right on top of your ventricle. And often this disease will just be from circulating calcium. It'll get stiffer, eventually not open, and you just won't get much blood flow out of your heart, right? It's called aortic stenosis. So the treatment for that has been open heart surgery, which has been a miracle, but you saw open the chest, stop the heart, your blood is pumped through a heart-lung machine, the surgeon carefully opens your heart, cuts out the diseased heart valve, carefully picking away all the calcium, right, and puts you all back together. And saved a lot of lives, incredible. But that's huge surgery. So you can picture when an idea came along that said, we don't think we need to stop the heart, we don't think we need to we don't think we need to remove the valve, it was very disruptive. So the idea was to make, and I'll just hold it up here, you won't be able to see it very well, but on a very small stainless alloy frame, put the 3 leaflets of the valve, and then just before the procedure, you squeeze it down into a small size on a balloon catheter. Picture this being on a 4-foot long tube. So a small hole in the upper thigh, move it right up your aorta, around the arch, over the diseased valve, inflate the balloon, push the diseased valve aside, and this immediately starts beating and supporting your life. And you go immediately from having limited blood flow to having blood flow that's rushing to your brain and organs like it hasn't for years. This tends to be a disease of the elderly, but it's a tremendous example of being able to apply a lot of cool technologies that were available and out there, and we have an industry that are full of people with great ideas to an incredible medical need. Now, it was disruptive because think of the whole community of surgeons that have honed their skills over decades on how to do this open heart procedure and get people to survive it and do well, and people do very well in that. But here's a way, and it's kind of this unusual one where I'll call it the triple win, where you can have improved mortality and all these, your cardiovascular system much better. Your quality of life gets an instant bump because all of a sudden, instead of having this setback of recovering from surgery, you're back at it, you're out of the hospital in a few days and going. And it's cost effective because you're not going through this intensive procedure that's debilitating, has a long hospital stay, et cetera. So that's the dream. Now getting through that and demonstrating that it really works, right, and getting the evidence to get people to change their minds, that's a strange and wonderful process, and it takes a lot of time, a lot of money, and it's one of the obstacles to really getting it to happen. We're one of the very fortunate success stories. So now there's been over 70,000 procedures done this way, 350 hospitals in Europe, another 350 in the US. And now some of these procedures are being done without anesthesia. So actually with the patient awake to replace your heart valve, which is almost mind-boggling to if you go back for any of us that have been around this for a while. So been a tremendous fun. And these patients, you wouldn't believe the experience for these patients. We've gotten to know so many of them. They tend to be the elderly. So the average age of the patient went through our trial was 83 years old. So you can picture that a lot of these folks, they've been through World War II and the Depression and you name it, and there's some tough people in there, and they're not willing to accept, you know, that they're just ready to go. And this isn't life in a nursing home. This is life back with their family, life doing things, starting charities, you name it. They're go-go, and it's impressive to see what it means to them.
Thank you. Thank you for humanizing it as well. It's really, and even your basic introduction was super helpful. Before we shift to Krista, just give us a sense of timeline. Like, how many years in development was this product? You know, any other indicators along those lines?
Okay, so here you go. The first heart valve was created in 1958. There was a guy by the name of Anderson that went to a meeting and he sketched something on a napkin and came home to his hospital in Denmark and put this in a couple of pigs in 1990. He was so impressed that this worked well. He wrote to every journal and so forth. He got completely shut down. His idea was ignored for 10 years. It got picked up around 2000 by some guys that had new faith. They started a little company around it. It's got some engineers from Israel. 2002, they did the first case like this with a patient. It was a patient that was expected to die within a matter of a week. And so then from 2002, it took till 2007 until it was approved in Europe, until 2011 until it was approved in the US, because we have higher standards and we expected a large clinical trial. So that's just the pathway to the first for each of these countries. And now we're still on a pathway of training hospitals and physicians and so forth. It's reimbursed by Medicare and Medicaid. That happened around 2011. That really helped because without payment, a lot of patients really can't access the technology.
It's interesting when you think of the word disruption, you kind of think of this instantaneous thing.
Not so
that's
instant,
a little different.
Not so instant, is it?
Yeah.
No.
And so, Krista, I know that the remotion knee has been in development for many years and has seen several iterations that you've illustrated here. Tell us a little bit more about that process, and also give us a sense of the unique market and partners that you're working with.
Sure. So our timeline is much shorter, as you can imagine. So the Remotion Knee project started actually as the Jaipur Knee project, and this is when the Jaipur Foot Clinic in India came to the Stanford class, as I mentioned. When the class was over, there was nowhere for the students to go. We absorbed them. I would say the biggest challenge, and one of the reasons why, and this is now 2008, 2009, we actually, so the first version, this Jaipur Knee, immediately went into use in 2009. So the Jaipur Foot Clinic took the prototype and said, oh my gosh, this works, this is high functionality, we are gonna start making it. And of course we were like, whoa, and the students we were working with were, whoa, 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 like we have to make sure it's consistent, high quality, we wanna be able to measure impact, all these sorts of things. We got all of that sorted out and then went into this product development where, you know, like 100 and some iterations later, we're now on this V3. But one of the biggest challenges we had in those early days is actually convincing the funding community and kind of the larger community at large a few things. One is that there was this high need in this low income population and that they actually deserved to have a high performance product. If you look at the history of product development, some of you might remember appropriate technology. What that really was these very rudimentary things that were laden with ideologies, like you should use local materials and it should be small and it should conform to these environmental standards, but it didn't serve the user, it didn't serve the customer. And even a lot of that kind of thinking still persists today. So the fact that we wanted to design this very high performance product at this low cost, we got a lot of, you can't do that. And I think that was for us like where the disruption started to happen because we were like, we're gonna do this. So we did do it, and I'll be quite honest, like DREV almost died several times because like people were working pro bono, and you know we were using like our board chair's house in the basement. But we did, and one of the things that helped is that the Jaipur Foot Clinic, remember they started using it right away, is we had this patient population that had been using our knee, and we were able to learn from them. We were able to learn they didn't like the clicking. We were able to learn that, you know, there's a lot of sensitivity about being identified about having a disability. So we kind of went through this learning process with our product, and I would also add is like it wasn't just with the product, but how clinics get their products, and you know, that needs to be part of our design process. And I would also say one of the big kind of disruptive areas in prosthetics and low-income areas is the supply chain. When we did field trials with the version 3, the black one that's wandering around now called the Remotion knee, we didn't just look for data on the patients who were wearing our knee. We were actually talking to the prosthetists. How do they make decisions about purchasing? What challenges do they face? And sometimes it was very obvious. One clinic in Nairobi, they had 4 skilled prosthetists, which it's actually quite rare to have so many skilled prosthetists in one clinic in some of these environments. And they were very busy, but they weren't fitting patients. And when I was able to talk to them, they said the feet didn't come in. So to give you context, when you have a above-knee amputation and you're fit with a system, you have a socket over your residual limb, you have the knee, which is what's being passed around, and it's the most complex component of that system. You have a pylon and a foot. So our knee wasn't getting put into use. The goal of our knee, which is to remobilize people, wasn't happening because of the foot. We might not be working on the foot, but that's a very real problem for us to change the environment. So as an organization, we said, we have to recognize this as a very real constraint. And if we want to solve the problem, we also need to focus, again, on this kind of unsexy area. So these things have been folded into our design process. Have we figured it out? We haven't totally figured it out, but we know where some of these pain points are and can start testing and experimenting on how to solve not just the technology problem, but this whole system issue to solve the bigger problem.
John, I can speak to the trajectory for exoskeletons briefly.
Sure.
In essence, it was a Russian scientist that patented the first exoskeleton in 1907. And then GE came up with this Hardy-Man, which was this 1,500-pound, totally impractical exoskeleton in 1961 that was designed to actually carry 1,500 pounds. So you can imagine this bulky thing, totally impractical. And then it wasn't until really the last decade, so 2000, that DARPA funded this military application, and then out of that was born the medical application in 2004. And that impractical barrier was broken, and we were able to, it's difficult to get a robot up and walking, but think how complex it is to get a paralyzed body within a robot up and walking. And so, in essence, we've created the most complex neuroprosthetic ever created. I can't speak to 3D printing, but that's going to take us even a step further. And now we've seen all of these different manufacturers of exoskeletons that have just come up within the last couple of years. And those manufacturers spread across the globe. So we've got Rewalk out of Israel. And they all have their very special qualities. But there's Rewalk from Israel, there's the Rex Bionics exoskeleton from New Zealand, and that helps a quadriplegic to stand up. It's a hands-free device. So someone who doesn't have full range of their arms can actually walk in it, and it's very stable and kind of big and bulky. We've got Cyberdyne that helps or Cyberdyne with the HAL robot out of Japan, Exo from Exo Bionics in California. And so we've got all of these different manufacturers out there. Dr. Nicolellis just came out with a very bulky brain-machine interface and kicked this soccer ball for the World Cup just last week. But it was, again, really bulky, but he's looking at a neural interface and a brain-machine interface. So that's now sparking and encouraging the other manufacturers to go, okay, well, how do we stay a step ahead? So we've got Exobionics, who's joined with another industry partner that's looking at a brain-machine interface or neural interface. And then we've also got Rex Bionics out of the University of Houston that is looking at the NeuroRex and how to actually, just thought-activated, have this machine walk. So it's speeding up. It's rapidly speeding up, and it is disruptive. What I've noticed with all of our panelists here is that the ultimate goal is quality of life. And that's what I see for any paralyzed individual, to get them up and walking. I think Tara, and yesterday at the opening session, Britta said, you know, sitting's the new smoking. Is that right? It's like, oh, I'm doomed.
Or you're ahead of the curve.
But I'm not, because I'm ahead of the curve, because I get to walk. But it's not just me. I'm just not the lucky girl that walks in a robot. And that's why I created the foundation, so that we can get it out. These exoskeletons are fully adjustable, and we can get communities up and walking. But we also talk about cost and affordability. And often people say to me, Amanda, this is totally not affordable for a person. We're looking at a $150,000 device. But then I go back to some of these prosthetic limbs that I see there's a gentleman in Basalt that's walking around. He's a triple amputee, and he's walking around on $145,000 worth of limbs, and that's one person. When we can look at $100,000 to get a whole community up and walking. So really, how much is an arm and a leg worth? When we're speaking of quality of life.
Fascinating. And I wanted to toss that back to Krista and just put a price point on the Remotion knee, and give us a sense of the units out there and the kind of adoption rate.
Yeah, so I want to pick up on Amanda's point, and one thing I do want to stress before I jump into your question, if it's okay, is that I do love what you mentioned about the disruption happens when a bunch of people are jumping in, right? And one of the things, my hope with DREV is we want to see competitors. We want to see more high quality, low cost products, more people jumping, because that's when the change happens, right? And that's when you that asymptote maybe, or what's the jump function, where you get that change. But going to the knee, so, Amanda, correct me if you know some of these numbers better, but a high-end prosthetic knee, you're looking at about $20,000. And this is something someone young and active would wear. It's got smart controls in it. Something, for example, like a young vet coming back from a war zone might be fit with. And then the price goes down, but so does the functionality. So the Remotion knee is priced at $80. It doesn't have all those smarts, but what it does have is it has a more natural gait based on this technology that was developed in the late 60s and early 70s. And just as a bit of context, the Red Cross knee is $150, I think I mentioned. So right now there's about 6,200 knees that are out there. The third version, the black one that's going around, will be launched later this year, and we've already gotten well over 250 requests. Most of them are from low-income countries where we've really been targeting it, patients who live on less than $4 a day. But even surprising to me, we've had over 24 requests from Americans. So if you're in the opening session, you would have heard this from me already. So there's also a huge demand for affordable, high-performance prosthetics, obviously, here. And what we hear from our patients and our customers is like, I have the $20,000 knee, and sometimes we hear it's more, but I'm not going to go kayaking in it because it might get wet, or I'm not going to go to the beach in it. So I would actually like your knee for those kinds of different activities. And I think it goes back to serving the lifestyles of and the needs and desires of your customers.
Fascinating. Robin?
I mean, I'm curious about, I want to comment about the cost issue. So, you know, with these shape memory polymers, I created another company to make next generation intraocular lenses. And so these are lenses that are used if you have end-stage cataracts and you need your lens replaced in your eye. So that where the technology is going is where they continue to make smaller and smaller incisions to insert this intraocular lens. And so our technology, we decided we were going to go sub 1.2 millimeters, which is one of the holy grails of intraocular lens treatments. And so we made it. We made a shape memory polymer intraocular lens that could go sub 1.2 millimeters. And we have a kind of a joint agreement with a larger company to develop it. And so when we're talking to the company, they said, well, you know, we can sell this for $600 because it is, like you said, it is a very, very functional device. But then, you know, I was in India recently, and I talked with a physician there in an eye clinic, and he said, well, we'd love to have your technology there, but, you know, for us, we need to sell it for $6. Mm-hmm. And that's what other companies that have grown in India are selling their intraocular lenses for. So now I have to bring it down by 2 orders of magnitude. How am I going to do that?
You can do it. I have faith.
Well, how do you set about going to
Well,
something like that?
That is a challenge, and honestly, I mean, appreciate your faith. I mean, I'm not sure. I think that, really we start out in the US, we go to Europe, we kind of introduce our products there, and hopefully that will kind of generate a sufficient kind of decrease in all of the upstream manufacturing costs and other things that we can start bringing down perhaps 1 order of magnitude. 2 orders of magnitude is still, I'm not sure. I mean, so the nice thing is that the materials are fairly inexpensive, right? But when we talk to this very large medical device company, they're very insistent that, that's one of the beauties of working in the medical device space. I mean, the hurdles to the market are huge. But you get to the market, then you can charge a fairly hefty premium. I mean, margins on medical devices are very large, much, much larger than consumer electronics or other things. And that's kind of the reward that you get. But with this other kind of complexity, that whole kind of mindset kind of has to change.
Okay. Let's go to Catherine, and then we're going to go to the audience.
Yeah, well, so I was just thinking in some of the themes of synergies that were emerging, and also in hurdles getting into the market. One of the things is that when you're trying to bring a new medical device out, you're trying to convince them, well, it works enough like all of these other medical devices out there that it's okay to be let out there. And that's not a recipe for revolution in a lot of ways. But when you see incremental improvements or even large improvements in several different areas that support one another. I mean, the thing that I'm thinking about is looking at new diagnostic technologies. Right now, we don't do a whole lot of screening because we hurt more people in the workup after a false positive than we save from finding actual cancers. But if our screening gets much better and we start to find cancers when they're the size of a pea and before they become clinically active, then we can use these incremental improvements that are happening in imaging technology to zero in on them, and these improvements that we've got in robotics to be able to just stick a needle in them and ablate them. And now we've fundamentally changed the way we approach and deal with cancer. Instead of, becomes more like we're all right having a mole taken off our skin and going home with a Band-Aid, but we could do that with all different kinds of cancers. We would treat them all like that. But that's not one product. That's synergy between 3 different advances in 3 different areas that really worked well together. And we see that with 3D printing changing the way we're doing planning, and we see it with things are coming into exoskeletons, and we see it with the technologies. And yeah, so no one of these things are revolutionary, but they combine to give us some really new capabilities.
Fantastic.
And speaking to the convergence of different technologies coming together with 3D systems, I wonder about your guy that's afraid to get his knee wet, because this is dishwasher safe. and it's really robust. It's so lightweight. It's nylon. It's
3D printed is what you're saying.
And this
start
is
selling CAD
3D
files for your intraocular lenses. You don't actually make them, they print their own.
So this is 3D printed from a person, so I wanted to emphasize that the exoskeletons that I referred to and the manufacturers that are out there, they're currently a rehabilitative device, but we're looking at when it becomes individualized, when it becomes something, a tool that I can use to enhance and augment my daily living. And that's coming as soon as next year. Indigo, with Parker Hannafin's coming out with functional electrical stimulation. But and so that's another company that's going to be challenging us to look at different things. But with this 3D printing, we're able to now take almost like my DNA, as I said, a scan of my body. And I become the robot, the technology becomes me. So it's that true technological, biological fusion. And that's what we're looking at, where this not only is robust and flexible and lightweight, but it's breathable, it's ventilated, and I can change any design that I want. This is created with the striations to look like my muscles, my musculature. And so we're going to go from what is currently known as an exoskeleton, and really it's my endoskeleton that supports me. It's allowing me to stand up on my own bones. But why don't we begin calling it exomusculature? So it's really an outer shell that becomes so slim that I slip into it like a snakeskin outfit. And it's the undergarment of my future.
Wow.
Why not? And we can pass this around too.
So who's willing to stand up and follow that? Let's go with the question, and let's try to direct questions specifically to somebody.
This is 3D printed as well.
Thank you, Amanda.
So
So I
this
saw
is-
a couple of hands over here.
When I talk about a kinematic art form of design and beauty, this is kinematic, moving. So this could become my dress or the snakeskin or the scales that works with my body.
And this is robust enough to hand around?
Yes.
Okay.
I think this stuff's indestructible. Is Scott Summit in the audience?
So let's go.
Oh, so Scott is, can I just, Scott is the key designer for 3D systems, and who I'll be co-presenting with and demonstrating the first 3D printed exoskeleton in the world, debuting on the stage tomorrow at noon. But what is it? Can you speak to that piece, Scott, really quickly?
That's a 3D printed complex mesh. Each
So in case anyone couldn't hear, because we do need to get the microphone passed. Thank you. So we'll go to this first question, but as we're getting the first question presenter standing up, the response was that the mesh that you see that Amanda just started passing around comes directly out of the machine looking just like that. It's a really remarkable thing to watch. I hope at some point everyone gets a chance to look at that kind of a process. So let's go for the first question.
The first question is really directed to Michael, but Catherine and other panelists might speak to it. Michael mentioned training, but no one really explained how you take a new valve or a new lens or Da Vinci robots and take the people that are going to deliver the clinical outcomes and change them from open heart to being able to use this safely and efficiently.
Fantastic question.
It's a great question, and actually, I'm going to create a little bit of conflict here because what I completely agree on is the way that we improve medicine is we do, especially with medical technologies, we do a lot of incremental changes. We create something and say, you know what, can you make it a little longer, a little softer, a little thinner, and one idea builds on another. And it's when those ideas come together that great things can happen. But unless somebody gets behind it and can study it and generate the evidence, medicine doesn't change. It's a cool idea that's out there, but you need the funding to go out there and actually, let's study this, not just in one hospital, but in many hospitals to show that it's reproducible in the case of hospitals. And let's actually follow these patients for not just weeks or months, but years to see what the long-term effect. And so that takes an investment. In the case of training, what we did is we invested actually in robotic technology and simulators so that physicians could practice. So what we insisted is whole teams would come in from the hospital, and we said, if you want to be part of this, here's the deal. You come in, you bring your team in, 2 days of training where you actually get to go through a simulation. Then you go back and you actually get proctored by somebody that was already an expert that stands over your shoulder for the first several cases until it happens. And so there's a very rigorous training program, and it took a big commitment on the part of those people that wanted to do it. And so it's kind of like, would you ever make that commitment if for just a little change? Probably not. It's almost you need to aggregate something that's significant enough to make that happen. And that's why I say not so simple to really get medicine to change. You know, and I love the passion.
Yeah, Robin.
So, I mean, one of the reasons when I had the opportunity to start the bioengineering program at the University of Colorado, I insisted that it be on the medical campus. You know, and that's one of the reasons is exactly what you're talking about. You know, we need the people who are making and inventing the technology to work hand in hand with the people who are going to be using and treating patients. I mean, that interaction is absolutely critical. And this part of the reason, so I'll use this heart again as an example. So it's a lot of the cardiac surgery fellows that are driving this, that are asking us to print 3D models so that, you know, they're tired of seeing it just on a 2D type of thing. They understand that the technology is here, and they're coming to us and saying, can you do this? So in their fellowship training, they are being exposed to these new types of technologies, and as a function of that, when they actually go off and become practicing physicians, they will incorporate some of these technologies as well. So it's absolutely critical to have the technologists and the clinicians kind of be working together as part of the training as well.
Excellent.
Yeah, well,
Excellent.
actually, if
Go
I
ahead,
could add
Catherine,
a little
sure.
on that. In the 12 years since the first Da Vinci's were brought out, we've been able to really observe how a technology like this really changes the way medicine is, or surgery is trained. And initially it was, we're open surgeons, we don't know how to do minimally invasive surgery, but also we don't know how to use this robotic interface. And there's an enormous amount of in-lab training, simulation-based training, all of these sorts of things to familiarize people with the tools. But this was largely done with surgeons who had been out in the medical field for a while. They were well out of their training. And so we were training people in a situation where ordinarily they're not still receiving training. So that was very strange in terms of the interactions in the hospital. As this device became much more ubiquitous and people were using it more, and eventually even standard of care in urology, what we saw is that the training was no longer being done by the company making the device. It was now being done in residency and fellowship training. It had become one of the tools that was in the armamentarium. And it was just one of the things that you were expected to know how to do when you got out of your surgical training. But not in every specialty. And so we saw it happen in urology first, and then we are seeing it happen in gynecology, and it may eventually happen in general surgery. But it's this classic movement of a new technology into a field that needs to figure out how it's going to adapt and use it.
Yeah, great. Such a great question and fantastic response as well. Another response over here, and then let's try to flip over to the other side of the room after this.
Hi, Rich Wager. I'd love to see a 3D printer in operation. Is there one in the valley that I might be able to observe? Amanda, would you?
They asked me to bring up one, but the problem was, you know, our printer, first of all, is huge. And second of all, there's a small window, and you hear some noises, and you see some lights, but it's hard to see it, you know. I mean, it takes some time.
It takes some time, yeah.
We print these things overnight, so we couldn't bring up our printer.
No, not just
But there
for me,
are
of course.
several consumer 3D printers now. MakerBot is one of them, and that's about this big. It can actually sit right on your desk, literally, and it too is a little slow, and it has a limited amount of range in terms of how big it can build.
Totally.
But there's increasingly some consumer solutions along those lines.
Is there one in Denver that I could observe?
I'm sure there's many in Denver. In fact, I don't know exactly where.
Okay, I
Scott,
got an
do you
answer.
know
Thanks.
Great.
that answer?
Oh, yeah, we're all getting there.
Let's move over to the other side of the room. There's one in Anderson Ranch in Snowmass Village, so perfect. In a whole digital department, fantastic.
And there's also YouTube, so you can check it out on YouTube, although I did notice someone
Yep.
smelling it as one of the pieces as I went around, so you will miss that part.
Okay, let's go to the next question over here.
Hi, my name is Sarika Bansal. I'm a journalist. I was wondering if, I'm not sure who this exactly would be directed towards, but I was really curious to learn more about co-creation and this whole idea of making people who are ultimately the end users, turning them into makers as well. I know that a lot of the disruptive technologies that you've been talking about are probably too advanced to do that, but how are all of you thinking about that in your work?
Fantastic question. Let's go with Amanda first on that one.
It was probably one of the most life-changing things for me when I became an integral part of the process. I was invited in, and the designers were interested to learn about me. What I love purple, and I like fashion. I like shoes. I got some pretty cool shoes right now. So they were interested in learning everything about Amanda so that they could eventually weave in my personality into the design itself. So we are a human race that loves to be individualized, and while we are unique, we're also the same. We always aspire to look pretty It's part of our culture, or handsome. And so to be brought into that, my body was scanned with a scanner that I think was a $500 scanner, but there were $30,000 scanners that used to do this. And then these images were cast onto a computer screen instantaneously. And then the designers designed the designs to fit onto what was a functional robot. And then my own body shape, you can even see the curvature. I've got a slight scoliosis. You can see the curvature. It's me. It's my blueprint on that robot that you'll see tomorrow when I walk on stage. And so it's about, it's like the wheelchair. When I got this wheelchair, I wanted it to be really small so I could turn on a dime and see more of Amanda. Well, now we're doing that. We're able to do that with the exoskeleton, so we see more of the person and less of the machine. And that's where we're merging. And that's where I was brought in as the co-creator. And I see eventually everybody will be able to be a part of their own design, not just taking a mold of their own body, but then to say, well, can it be this shape? Can it have filigree lace that's rainbow colored, like my iPhone cover? You know, and we'll be able to interact here. That's where I see it's going. It's actually happening right now. It's not a wave of the future, it's now.
Great. Thank you, Amanda. I think that was a fantastic response to Sarika's question. We are in our final moments of this 60-minute session here. I wanted to point out, related to that last question, that some of the, what I've seen as an architect and now as a funder, some of the most incredible advances as it relates to the type of design that Krista and others are practicing are being led by women. And that's not something that historically has been the case in design. And so I was thrilled, of course, then to have three amazing women join us up on stage for this session. I think that it's this whole kind of user-centered design process, or human-centered design process, centers around empathy. And that's something that I've seen the women leaders in our field really take hold of and demonstrate how to do it most effectively. And so there's a lot of just incredible momentum behind some of the initiatives that we're seeing with Krista's work and Catherine's and others. And it's really fantastic to see. Since we are running out of time, we probably don't even have another moment for one last question. I wanted to first start by thanking our wonderful panelists, Catherine, Michael, Amanda, Krista, and Robin. Let's give them a huge round of applause. And secondly, if you enjoyed this session and you enjoyed hearing, particularly from Amanda, from this kind of end user perspective, but also from some of these other experts in their own way at the forefront of their fields, I want to extend a special invitation for you all to join us for a session called Undaunted that is starting at 5:30 tonight at the Hotel Jerome, runs from 5:30 to 6:30. There are 10 emerging leaders in global health, 8 from Africa, 1 from Haiti, 1 from India, and they're part of the Aspen Institute's New Voices Fellowship Program funded by the Gates Foundation. They're going to be telling very personal stories about why they do what they do. And again, we got a taste for a little bit of that with the various people up here on the stage with us today. Really hope that you'll join us for this next session at 5:30, and want to thank everyone for being a part of this discussion.
Can I say one thing?
One thing.
So I apologize, I had no knee or thing to hand around, but if you do want to play with the Da Vinci robot, there's one over in the Sinai tent. So you can go play around.
And these other products are on display as well.
Yes.
Excellent. Products on display. Fantastic. Thank you all so much.